Today, we're diving into the most powerful, the most spectacular, and, yeah, the most violent explosions that exist anywhere in the universe. I mean, forget supernova. These things are in a totally different league. We're talking about gamma-ray bursts. Just try to wrap your head around this number. In just a few seconds, literally the blink of an eye, a single gamma-ray burst can unleash more energy than our sun will in its entire 10 billion-year lifetime. That's an amount of power that's almost impossible to really process.
And hey, this isn't just some wild theory. Back on October 9th, 2022, we actually saw one of these monsters. It was called GRB 221009A, but it got a much better nickname, the Boat, for brightest of all time. It was so intense, it just completely blew out our detectors. And get this, it was powerful enough to actually disturb Earth's upper atmosphere, our ionosphere, from over 2 billion light-years away. That's the kind of cosmic titan we're dealing with.
Okay, so let's get into the physics of this. When we say these are the biggest bangs out there, we are not kidding. The only thing in the entire history of the cosmos that was more powerful than a gamma-ray burst was the Big Bang itself. These things are so extreme that they're often the birth announcement for a brand new black hole.
So how in the world does one event get so bright? Well, the trick is, the energy isn't just blasted out in every direction like a regular explosion. No, it's focused. It's channeled into these two incredibly narrow jets of plasma. And these jets are fired out at something like 99.99% the speed of light. I mean, we're talking the universe's speed limit. If one of those jets happens to be pointed right at us here on Earth, we see this unbelievably bright flash. It's literally like staring straight down the barrel of a cosmic cannon.
You know, the story of how we even found these things is almost as wild as the bursts themselves. It wasn't some astronomer in an observatory patiently looking for them. Nope, it was a complete accident born out of the paranoia of the Cold War, and it kicked off one of the greatest scientific mysteries of our time.
Okay, so picture this. It's the 1960s. The US has these satellites called Vela, and their job is to look for secret Soviet nuclear bomb tests. But the satellites kept picking up these super intense flashes of gamma rays. The thing is, they weren't coming from Earth. They were coming from deep space. For years, the data was totally classified. When it was finally published in '73, scientists were just baffled. The mystery wasn't really solved until the 1990s, when a NASA observatory proved these bursts were coming from billions of light-years away, which meant they had to have an energy source that just seemed impossible at the time.
So after decades of scratching their heads, astronomers finally cracked it. They realized they weren't just looking at one thing, but two. There are actually two different kinds of gamma-ray bursts, and they come from two very different but equally catastrophic cosmic events. And believe it or not, the dividing line between them is just 2 seconds. Anything longer than 2 seconds is a long GRB, and it comes from the death of a single giant star in what's called a collapsar. Anything shorter than 2 seconds is a short GRB, and that's the result of a cosmic pileup. Two super-dense neutron stars spiraling into each other and merging. So one way, a black hole is born from a collapsing star. The other way, it's born from a collision. Let's just walk through that long GRB model really quick. First, you take a star that's at least 20 times more massive than our sun. When it runs out of fuel, its own gravity becomes too much and the core just implodes. Bam! A black hole is born right in the middle, and it's surrounded by this swirling disk of matter. Finally, that disk acts like a giant cosmic engine, launching those powerful jets that have to blast their way out through the rest of the dying star. That eruption is the gamma-ray burst. Okay, so they're unbelievably powerful, we get it. But why should we care? What does this mean for us? Well, it turns out these incredibly violent explosions are also some of our most valuable tools for science. They're like lighthouses that let us see across the universe, and they're also cosmic gold mines that create the most precious elements. Because these things are so blindingly bright, we can see them from the absolute edge of the observable universe. Their light shines across billions of years, acting like a probe that lets us study what the cosmos was like when it was just a baby. For instance, there was one called GRB 090423. Its light traveled for over 13 billion years to get to us. It gave us a snapshot of the universe in its absolute infancy. This all leads to this incredible new field called multi-messenger astronomy. And the idea is actually pretty simple, but it's totally revolutionary. Instead of just looking at something happening in space with a telescope, we can now also listen for it using gravitational waves, actual ripples in spacetime. By combining these two messengers, light and gravity, we get a much fuller picture of what's going on. And in August of 2017, it happened. This was a huge moment. For the very first time, scientists detected gravitational waves from two neutron stars crashing into each other. Just moments later, our gamma-ray telescope saw a short GRB from that exact same spot in the sky. It was the ultimate smoking gun. It proved once and for all that short GRBs come from these mergers, and it officially kicked off the era of multi-messenger astronomy.
So when we ask again, why do these things matter? Well, the answers are just profound. The collision that makes a short GRB is also a cosmic factory. The gold on your finger, the platinum in your jewelry, it was almost certainly forged in a cataclysm exactly like this billions of years ago. These events are also natural labs, testing physics in ways we could never dream of on Earth. They let us peek into the early universe, they prove Einstein's theories right, and they might even be the source of the most energetic particles in the entire cosmos.
But this story is far from over. I mean, this is one of the fastest moving fields in all of astronomy, and it seems like every time we find a new one, it just raises a whole new set of questions. We're really just scratching the surface of these cosmic fireworks. In fact, you know that neat two-category system we talked about? Yeah, the universe doesn't really care about our neat little boxes. We've started seeing ultra-long GRBs that last for hours, not seconds. And we've clocked jets moving so mind-bogglingly close to the speed of light, it's almost unbelievable. The universe always finds new ways to surprise us. So this all brings us to the big question, right? As our new observatories like the James Webb Space Telescope stare deeper and deeper into space, what else are we going to find? What other cosmic secrets are hiding inside these brief, brilliant flashes of light from across the universe? And I think that's the most amazing thing to take away from all this. These events, the most violent, destructive moments the universe has to offer, they aren't just about destruction. They are profound storytellers. They carry the tales of how black holes are born, how gold is made, and the entire history of the cosmos itself, all of it encoded in a fleeting, brilliant burst of light.